Welcome to The Blueprint of Truth, a sensor maker's guide to navigating statistics. This video will explore the core concepts that form the basis of statistical reasoning and inference, using the normal distribution as our central theme. Statistics is fundamentally divided into two acts. Act 1 is descriptive statistics, focused on organizing and presenting raw data. Act 2 is inferential statistics, where we project findings from a limited sample to make broader generalizations about a vast population. Understanding the source is key. A population is the complete set of observations, while a sample is the selected subset. A parameter describes the population, and a statistic describes the sample. The rule of randomness demands a random sample to prevent bias. Measures of central tendency include the mean, the exact balancing point, which is sensitive to outliers. The median is the center cut that divides the set evenly. Finally, the mode is the observation with the absolute greatest frequency. Dispersion measures the spread of data. Variance is the average of squared differences from the mean. Standard deviation translates this back into the original units of measurement, providing the average distance from the center. Data can be visualized in different shapes. A histogram shows the frequency of occurrence. A symmetrical or normal curve has the mean, median, and mode aligned. A skewed curve shows an imbalance in the data. In probability, the sample space includes all possible outcomes. Mutually exclusive events cannot occur simultaneously. Independent events have probabilities unaffected by one another, while dependent events change based on the other's occurrence. Distributions are categorized into discrete models for counting, like binomial, Poisson, and hypergeometric. Continuous models are for measuring, with the normal distribution being the primary model where values cluster symmetrically. The standard normal distribution is a benchmark where the mean equals 0 and the standard deviation is 1. The z-value is the universal translator, measuring the exact number of standard deviations an observation lies from the mean. The Central Limit Theorem is fundamental. The magic is that if you draw all possible samples of a given size, the distribution of those sample means will form a perfect normal curve as the sample size increases, typically for n greater than or equal to 30. Hypothesis testing uses the null hypothesis, the status quo, and the alternative hypothesis, the claim. We use the concept of indirect proof, establishing a level of significance to determine the threshold where chance is no longer a believable excuse for rejecting the null. When making decisions, a type 1 error is a false positive, rejecting a true null hypothesis. A type 2 error is a false negative, accepting a false null hypothesis. The trade-off means lowering the level of significance to prevent type 1 errors increases the risk of type 2 errors. The standard error is the measure of variability in sample means around their expected value. Confidence intervals construct an interval within which the hypothesis remains tenable. Wider intervals offer more confidence but less precision in the claim. Selecting your statistical tool depends on your research question. Use z-test or t-test for testing means. ANOVA compares the effect of more than two groups. The chi-square test analyzes categories, and the runs test checks if a sequence is random. Correlation measures the strength and direction of relationships. A positive trend moves together, while a negative trend moves in opposite directions. Ultimately, statistics is a systematic blueprint for managing uncertainty and revealing the truth hidden in raw data.